Okay, hey, hope everybody's doing well. I'm back with the power supply that the cap, I think the cap is bad. So this is a SMPT switch mode power supply. And anyway, so I'm suspecting that this cap is bad. And in two other videos, this is going to be the third part of the design. It's called the Blackmagicdesign television. Let me get it here. It's right here. It's the Blackmagic ATEM Television Studio Pro HD unit that the internal power supply has gone out. Yeah, which is an SMPT, which is this guy right here. And I'm thinking, in the other two videos I talked about this, and I want to say that this guy is, it tested on the low end, it's a 400 volt, 100 microfarad capacitor, and I don't know, it tested like at 83 microfarads, although the what do you call it, the equivalent series resistance was a little high. And so I'm going to compare this to a new one, to known good one, and let's just compare it. I have my this is a inductance, capacitor, and resistor analyzer, and then I have a handheld one, this one right here. We'll test it with both of these guys. I know the one at school, it's a Sencor one, and when I tested this guy at school, again it measured 83.2 or 3 microfarads, and then at the top it said good. Obviously, because pretty much all capacitors are pretty much plus or minus 20%. So that value that's written on the side here can be within that range. But the ESR was like 3 point something ohms, and I think that's a little too high. And like I said in the other videos, if this guy is, if I put the new one in there and it still works, you know what, I'm out. I think I bought one was $2.20 something cents. The other one was $4. You know, I'm not out a lot of money. The unit is still going to work because I did do an external power supply for it, and I'm showing that in the other videos. I think it was part 2 where I did that. So anyway, so SMPT, the way they work, just briefly, AC comes in here. Sometimes they take it to a transformer and they step up the transformer right here. Let me get in real close because I know it's hard to see because there's a lot of black and there's not very much light on this. And they step it up, and then this black guy right here, this long one, that guy is a bridge rectifier. And so they take AC, in a nutshell, take AC, then they rectify it to DC at a higher voltage, then they filter out the DC with this, and then they take it through a switching unit. Yeah, and I don't know if this is the switching capacitor, or I'm sorry, the switching transistor. But there's a transistor here and a transistor here, and one of these is a diode. I can't remember which one it is, but anyway. So what they do is they bring AC, they convert it to DC, they filter it out, filter out any little, whatchamacallit, ripple, AC ripple. And then there's some chips underneath here. There's a switching chip, and then there's a power factor chip. And so let me just take it apart real quick. Anyway, so then it goes through the transformer. This is a transformer, and they're switching the DC on one side of the transformer, okay, at a high voltage. Probably, I think I checked this, and I want to say it was at 160. I want to say it was 160 volts. You know. Anyway, so then they're taking that DC and they're switching it here. So now if you studied electronics, in order for a transformer to work, and I don't mean Transformer the movies, just think of a transformer as just a coil of wire. And if you have a coil of wire on one side and you have a coil of wire close to it, okay, what you get is magnetic inductance. And so what they do is on one side, they're switching on and off the DC, which is kind of a square wave in this case. And in order for that to create a magnetic field, the current or the current going through the coil has to be changing in time. In other words, it has to be turning on, turning off, turning on, turning off, turning on, turning off. And what happens is you create a magnetic field, and through magnetic induction on the other coil on the other side of this guy, because of that magnetic field that gets created, it also induces a current on the other side. And so then you have a voltage also. And then so what they do is they filter out that voltage to whatever, in this case it's a 12 volt power supply at 3.5 amps or something like that, and that's what this is. Okay, now there are some real fancy, and I know it's hard to see, but there's a chip here, there's a chip there, and some transistors and resistors and all that. And so one of these guys, I want to say this is probably the switching, yeah, this is going to be the switching chip, if I'm not mistaken. This is a switching chip. And yeah, and then this also may be a switching chip over here on this side. I'd have to look up the numbers and stuff, but I'm not going to get into that real deep, but basically I'm just trying to tell you these are really sophisticated power supplies. Sometimes they're very easy to repair, and other times, they may not be easy, and that may be the case in this, but I'm suspecting this guy to be bad. Okay, so I'm gonna solder sucker this out with my pay system over here. I'm gonna take that out, and then we'll compare it here. We'll compare it. This is a Matrix MCR 5100, and the frequencies that you can test are from 40 all the way up to 100,000 hertz. So, and I think you can see it right now. I have it on CS for capacitance, and RS is the series resistance. So we'll be measuring that, and we'll also use this one here. So anyway, first of all, I really don't even need this until, well, you know what, let's use it. Let me put it on here. I got it out, might as well use it, right? So I don't know, this today's June 3rd, actually June 4th, 2023, and I'm off of school. I teach electronics at school, AC/DC electronics and stuff, and I've actually taught my kids some, I've taught them a little bit on how to repair stuff. I'm basically doing all the work, and they're kind of watching. It's kind of sad that's what that class has become. When I was over at another place, we had a lab and a classroom, and so I could go into the lab and they could do all these experiments hands-on and stuff. And anyway, that's another story. But all right, so basically, to get this out, I had this desoldering machine, and and so what happens, I need to get, I'll have some solder right here. So what happens is this guy has a hole in it. And I already know where the points are. They're right here. Okay. And let me get this a little bit closer. I don't know if it'll focus there, but this is the guy. And when you're working with these, you basically want to have this tipped probably a little bit down this way, because you want the solder to run into this guy. If you're doing this, if you're trying to solder suck like this, it will suck it up, but it might get caught in between here. This is very, very hot. And then it clogs up, and you have that clogging up problem. So anyway, so I put it on here. It'll melt, and then once it melts, I press it, and it sucks it right off. Okay, let's go to the next one. So it melts, press it, and that's it. And you always want to clean your tip before and after every time you use it. Okay, so now this thing should come out fairly easy. And there it is. All right, so I'm going to put this aside. Okay, so I think everybody can see that right there. I'll put it over here a little bit closer. All right. So I believe on this type of meter, I don't think there's a zeroing out of the leads. At least I haven't found how to do that on this, and I've seen some videos online on this guy, and the guys who use it just hook it up. So a capacitor, let me pull this off here. This is a little protection, and so on here, and this is the negative, and I'll put it on there, and we'll let it go. All right, so this is reading at 100 megahertz. I'm going to lower the frequency because this guy is coming in at, or rather the AC that's coming in is at 60 hertz, more or less. So I'm going to go down to 60 hertz, and I just need to figure out how to do this because I haven't done this in a while. Let's see. There you go. And then I'm going to decrease to there. Let me go down to 60 hertz. All right, well, it's suggesting, oop, that just came off. So 86 microfarads at 0.9 series resistance, you know, it's pretty good. I mean, at work, on the one I was using at work, I was getting like 3 ohms for the equivalent series resistance. So, that's kind of interesting. Auto ranging slow. 1 volt. All right. So let me write that down here. I'll write it down. Get a pen. Write this stuff down. So we're getting with the matrix, we're getting 86.191 microfarads at, well, it's at 400, but it's, and then RS, the resistance, equivalent resistance is 0.9069 ohms, which ain't bad. I don't think it's bad. Let me go down on decrease to 40. Yeah, you see now it's like 1. Let me increase. That's 100 hertz. Let's go another one. That's 1 kilohertz. Interesting. Okay. All right. Let me grab the known good one. And you know what? This may be a unit that I can't repair, and I may just order a new power supply for it. All right. So this is 100, 400, and 100 microfarads. So let's see what this one comes out to be. This is the negative. All right, let's see what it's. All right. And the new one, this is the old or used, and then the new one we're getting at 85.74 microfarads at an RS 0.5306 ohms. Wow. Okay. Again, you know, there may be, I mean, that's fairly decent, you know. And also this one, it's still within the range. Let me check something else out. Let me take this off. Let me grab one of these. This is another one I ordered with a little bit more capacitance. This is 120 microfarads. Yeah, 120 microfarads. So let's see what this one will tell us. All right, that's 105.7 at 0.38 microfarad. So let me put this one here. So 400 volts at 120 microfarads, and I'm getting 105.7 microfarads, and RS is 0.3737 ohms. Okay. All right. You know, so far, it's possible that there's something else wrong, you know, in this guy. But we'll find out. We'll put the new one in there because, I mean, who knows? You know, this thing may test good out of the circuit, but once you put it in the circuit, you know, under load, it may behave a little bit different. Possibility. I'll find out here in a bit. Okay, now let's test it. Let's test it with this guy here. Let's see what this one says. All right, now this is a little bit different because we have to do calculate, let's see, series. Oh, okay, let me do. Hold that. I think we got to hold it for a while. There we go. All right, so it's calibrating open, open circuit. Let me put this over here. It does a 30-second test, and then I'm going to short them out and do a test that way. Okay, passed. So now we do short SRT on there. It says to short these guys out. And then all right. So, all right, pass. So now we kind of get out of that. And now I'm going to connect the capacitor that I took out. It's negative. That is positive. Put it on there. And it's kilohertz. Let me change the frequency and see if I can go down 10. All right, 100 hertz. and then ESR, come on. Now to ESR, there we go. And so this is my DERE 5000, and it's giving me a reading. This is the guy that I pulled out of the unit. It's giving me 85.73 microfarads, and the equivalent resistance is 0.7 ohms. You know, again, there may be some other thing bad with that unit, and this is the new 400 volt at 100 microfarads. Let's put that guy on here. And that one's coming in at 85.49 microfarads, and the RS is 0.4 ohms, which is not bad. That's not bad. And then let's try this one. This is the 120 microfarad one. And this one is measuring 105.42 microfarads and 0.2 ohms for equivalent resistance. Okay, I'm just writing them. I'm writing the stuff down just so that I can have record. Again, like I've said, this guy may be good, but under load, who knows? I don't know. I really don't know. So what I'm going to do is I'm going to go ahead and replace this with, I guess with the original, 400 volt at 100 microfarad, and see if it'll work. And if it doesn't, well, like I said, I'm out $2 and stuff, and this power supply, you can buy the whole power supply for $80 or something on what do you call it, Amazon. So let me put this aside. Turn it off. Don't need that anymore. And I'll go ahead and put this guy in. We'll solder it. That's negative. Well, definitely need to bend the leads here. Just bending the leads on it. And I guess I could put this guy on. And alrighty, let's see what'll happen here. Okie dokie. And we'll kind of do this number. My glasses. All right. So let's do this guy first over here. And let's do this guy over here. All right. So now I'm just I'll clip these leads. I'll just clip them. I'll put it in the unit, and we'll see if it'll work. If it doesn't, then either one of these chips down here has gone bad, or it's possible something else has gone bad here.